We know the definition of relation, function, domain, range. We've seen some examples of evaluating functions and just kind of generally working with functions. We haven't talked about domain and range too much yet. We better do that. So again, domain and range. Domain is just a set of all possible x values, all possible inputs. Range is all possible outputs. And so we want to find the domain and range for each of these. Okay, so the good question that you're all probably wondering is how do we do this? Okay, let's just maybe do some thinking. Okay, we kind of have to just work with the definition. So a set of all possible x values. Okay, so let's maybe just start there. Okay, um, really we can refine our definition of domain. It's all possible domain values that produce a valid output, right? So if we put something in, we want something out. If we put something in, it doesn't produce something out, then, well, that's a bad thing, right? So with that idea, let's see if there's values that we put in that we can't get anything out of from the function. So with f, okay, I'm thinking, okay, we probably already have this in our brain, but you might have a picture of what this graph looks like. We haven't talked about graphs, but maybe you have a picture of that. But I'm thinking, what can I put in? And then what will I get out? So if I put in, say, 5, okay, I would get out 6, right? If I put in 7, I get out 8. So everything is just shifted, right? If I put in 0, I get 1. If I put in negative 52, I get negative 51, right? So I can, in this case, I can put in, so I'm going to say my domain, I can put in any real number. So ways we can communicate that, double bar R, okay, that means all real numbers. You can also write this in interval notation as minus infinity to infinity, right? X can be in that range, okay? And then similarly, when we talk about range, right, what do we get out? I was mentioning, if I put in 5, I get 6. If I put in negative 52, I get negative 51, right? If I put in 0, I get 1. What I get out is it's in the range of any real number, right? So again, you could say this is double bar R to minus infinity. Or sorry, double bar R or minus infinity to infinity if you put it in interval notation. Okay. So that one's a little easy. Let's go on and do the next one. Okay. I'm looking at g of t. Okay, so there's a numerator, there's a denominator. It's a little scary because fractions, right? But I'm looking at that and I'm saying, okay, well, if I put in 0, I get something out. Yeah, that's fine. Put in 0, I get what? Minus 2. I put in 2, I get out 4. If I put in 1, I get out, uh-oh. If I put in 1, I'd get 3 over 0, right? So if I do like g of 1, I do 2 plus 1 over 1 minus 1, I'd get 3 over 0. That isn't good. I can't divide by 0, right? That's not good. So I noticed that the value of 1 is the value that made the denominator 0. So that is not good. I can't have the denominator being 0. So another way to do that more algebraically would be to say, okay, let's take the denominator, whatever I have in there, and say that that cannot be 0, right? So this is saying that t cannot be 1, okay? So a good procedure is if you have a denominator present, make sure that that denominator cannot be 0, okay? If otherwise, find where it is 0, remove those values, okay? So in this case, we can say when we look at the domain that it is going to be all real numbers except, so you have to do kind of a forward slash for that one, except 1, okay? If you were communicating this in interval notation, it would be all real numbers, so minus infinity to 1, we'd have a boundary, union, okay, because we have a second piece, second interval, 1 to infinity, okay? Because the number line would look, I don't have much room, I'll do it here. We'd have, at 1, we'd have a hole, and we would have everything apart from that, so that's why we have the two pieces. One piece of information here, we don't much care if the numerator is 0, right? If I let t equal -2, right, that would make the denominator 0, so I'd have 0 over -3, right? And 0 divided by a number, that's always just 0, okay? That's totally fine. I don't care if the numerator is 0, I care if the denominator is 0, okay? The range for this. Range is going to be a little tricky, and in fact, I generally do not like finding the range algebraically, because what you end up doing is literally having to test many values, okay? This one, what I would say is do a table of values. So do like a t and a g of t table and test values on both sides of 1. So, -2, -1, 0, and then I would get really close to 1, so like 0.5, point, zero point 0.9, 0.99, and then 1.01, 1.1, and then 2, 3, and just see what happens. Okay. I can tell you with this one, this is going to be 0, and then in here you get, as you go closer towards 1 on this side, you get larger negative numbers, okay? Over here, you're going to get large positive numbers, okay? So, and then as you get further out, you're going to get closer to 1, okay? So this one, I don't like finding the range algebraically because it is literally just a bunch of plugging and guessing and checking and seeing what you get. The range ends up being -infinity to 1 union 1 to infinity. Okay, we'll confirm this in another method coming up. Okay, so h of p. Okay, I want to find the domain. Okay, so what values can I put in to get out a defined value? So I'm thinking, can I? I'm just going to maybe try a p and an h of p chart just to get an idea. So 0. If I put in 0, I get square root 5. Okay, if I put in 1, I get square root 3. If I put in 2, I get 1. If I put in 3, I get square root of -1. And in this course, we do not deal with negative square roots. Okay, you might know imaginary numbers, we don't deal with them. Okay, so, okay, that doesn't work. What about -1? If I put in -1, I'd get square root of square root of 7, right? Okay, that works. And you can actually keep going if you want. Okay, in a different vein, you could actually say, okay, well, what do I know about square roots? I know that the stuff underneath square roots has to be positive or 0, okay, if it's in the numerator. So 5 minus 2p must be greater than or equal to 0. Oh, it's an inequality, right? We like solving inequalities. Okay, add 2p to both sides, plus 2p plus 2p. 5 is greater than or equal to 2p. I'm going to write that differently because my brain needs the variable on the left for some reason. Divide by 2, divide by 2. P is less than or equal to 5 halves. Oh, and we know how to write that. Like, okay, I'm just thinking like interval, right? We'd have parentheses here going that way, which that means that the domain in interval notation would be -infinity. Oops, that should be like that. My bad. -infinity to 5 halves bracket. Okay, that's fine. And the range here, the range you might have to do a little bit of thinking, but what do we know about square roots, right? The square roots, they output 0 and anything positive, okay? So basic square roots are always going to have this particular range from 0 to infinity, inclusive at 0, okay? So just to kind of summarize, what did we learn about domain and range, okay? Domain, okay? Find the numbers that we need to exclude, right? Or anything that doesn't make sense, right? Anything that causes us to divide by 0 produces a negative under a square root, right? Or something weird, right? We didn't really get an example of that case, but it doesn't happen too frequently, okay? So then the domain is all numbers that are not excluded. So again, in the case of the square root, I had to exclude anything that would be beyond 5/2. In the case of G, right, I had to exclude 1. And the first one, I didn't have anything excluded, okay? The range, again, evaluate the functions that very close to any excluded domain numbers. It'll give you, if it goes to positive or negative infinity or 0 or neither, okay? And then otherwise, just honestly, you have to try evaluating, okay? And we are probably going to save range for when we are able to produce graphs, just because it's easier to do it once we have that tool, okay?